Continuing from the last lesson in which we found many relations from set A to set B, let's take an example where we have set A which is equal to 1, 2, 3 and another set B which is equal to AB. And let's define one relation named R from A to B so that R is equal to 1A, 1B, 2A and 2B. And let's take one more pair, 3A. Now, collection of first element of every ordered pair in this relation will be called domain of this relation. So collection of first element of all ordered pairs in the relation is called domain of relation. Domain of relation, and it is denoted by some time down of the given relation equal to. Now, which are the first elements of every ordered pair? This, and this. So this collection is going to be 1, 1, then 2, then 2 again, and then 3. So this is collection of first element of every ordered pair in the given relation. And the collection of second element, collection of second element of each ordered pair in the relation is called range of relation. Range of relation. So obviously in this case, range of R is going to be A, then B, then A, then B again, and then A. So this is range of relation. So just to revise, collection of first element of every ordered pair in the given relation will be called domain of the relation, and collection of the second element of every ordered pair in the given relation will be called range of the relation. So some of the relations could be called functions and the others can't be called functions. What is the distinction? So let's define function. Function a relation R from A set to another set B is called function if the following two conditions are satisfied. What is the first condition? The first condition is that no element in the domain is repeated. So domain must contain all elements which are distinct. And number two, domain must be equal to, domain is equal to set A. These two conditions, and notice that both of these conditions are on the domain. There is no condition on the range. So a relation can be called a function if the domain contains distinct elements only and domain of the relation is equal to the set A. Let's take a look at one more example in which we are not going to use two different sets, rather we are going to use one set. Example, find three functions and this time we are going to name it f from A to A, where A is equal to A, B, C. Now this time you can see from the example that the A and the A and B are not two distinct elements, rather we are mapping elements of A again in with the elements of A itself. So these are called binary relations, and then of course some of those binary relations will be functions and some will not be functions. So here the job is we need to find out three such relations which will qualify these two conditions and hence will be called functions. So first we are going to find out three such, it would be easier if we find A cross A. A cross A will contain how many elements? A cross A must contain 3 times 3, in total of 9 pairs. So those would be AA, AB, AC, and then BA, BB, BC, CA, CB, and CC. We need three subsets of A cross A which can qualify those two conditions. So let's call it F1, which is one relation, and we are going to take A, B, and C. And another one will be F2. This will be equal to AB, BC, and CA. So, and F3 we can take as AC, BA, and CC. All these three relations F1, F2 and F3 are functions. The reason, because domain of F1 is equal to what? A, B, C, the first element of every pair, A, B, C. It meets both those conditions. No element in domain of F1 is being repeated, and it is equal to set A, and no repetition. And similarly, if you look at F2, what is the domain? The domain of F2 is collection of first elements of every ordered pair, A, B, C again, A, B, C. No element, of course, is repeating itself, and also this is equal to A, again no repetition. And similarly, F3, the domain of F3 is equal to ABC again, ABC, and it is equal to set A, and again no repetition. So this is how we can find relations, and then some of those relations are obviously functions. But to identify which one of the relations are function, we look at these conditions, that domain of that relation must be equal to set A, and the no element in that domain must repeat itself. So such relations will be called functions. If we try to define functions in another way, let's write down a definition of function, which apparently seems a little bit different, but actually this is exactly what it entails to. So another definition of function, function. A function is a rule which assigns to each element x belonging to A unique y belonging to B. X and y are obviously the placeholder for elements of A as well as for elements of B. So if these two conditions, which one are those conditions? For which a function is a rule which assigns to each element x belonging to A. If you read this definition, if you read this sentence carefully, essentially it means that we have to assign an element of B to every element of set A. So the domain must be equal to set A. And then it says a unique y belonging to B. Unique means that the domain cannot contain multiple elements. If we try to write we try to clear this concept with a couple of examples. Here is set A, and here is set B, and let's call this relation F1, 2, 3 and 4, A, B, associated to A, 2 is associated to B, 4 is associated with C, 3 is associated with D. What is the domain? Domain of function is equal to all those elements of A which have image in B. That is, those are called the domain. So this is of course going to be 1, 2, 3 and 4, which of course is equal to set A. And the range of F is equal to A, B, C and D. And also you can see no repetition. So none of the element in the domain is being repeated and they are equal to set A. So that's why this relation is called a function. Also the range is equal to A, B, C, D. Now let's take another example. And in this example, we are going to say f from A to B. Is f from A to B a function? Where A is equal to A, B, C, D and B is equal to 0, 1. If we draw the same figure, let's say this is A, this is B and F is this relation. So here A, B, C, D and 0, 1. A is associated with 0, B is associated with 1 and C is associated with no element in B and D is associated with 0 again. So what is domain? And if this relation is a function, then domain of the function f is equal to, so now this time we are going to take a look on the elements of A which do have image in set B. A does have an image because there is one line that originates from A, so A does have an image, B does have an image and D does have an image. But as you can see, this is not equal to A because C doesn't have any image. If we were to write this relation in tabular form, then we definitely would have written as A0 and then B1 and then D0. This is pictorial representation and this is in tabular form. Clearly domain of this is AB. So domain, like we read before, is equal to A, B, D, which is not equal to A. Our second condition got violated because it should be equal to A if this relation was to be called a function. And now types of functions. So f is not a function. Now we are going to say one functions. One function. A function f from A to B is called one function if all the elements in range are distinct. This is the same condition we had on domain for a relation to be a function, but there was no condition on the range while we were defining function. But in addition to the definition of function, like in addition to those two conditions which we need to meet in order for a relation to become a function, if this condition of distinct elements is satisfied for the range of the function, then such a function will be called one function. And onto functions. Onto function is another kind of function. And onto function. A function f from A to B is called onto function if range of the function is equal to the second set, is equal to B. Like clearly you can see these are both conditions which a function needed to qualify in order to be called, in order for that relation to be called a function. But those conditions were on domain. Now we are talking about the same those two conditions, but this time we are talking about these conditions with reference to the range. If range of the function does have distinct elements, then that function will be called one function. If the range of the function is equal to set B, then it's called onto function. And if a function is both one as well as onto function, then it is called a bijective function. So in the last, we are going to write down the definition for bijective function. Bijective function. A function f from A to B is called bijective if it is both one and onto. Well, at this level, this is enough for the definition of function as well as types of the function, but we are going to visit this topic again for higher level of mathematics, and we will just pick up this concept from where we are leaving it right now, and we'll see you in the next chapter. That will be real number systems.